The evolution of architectural design principles constantly redefines the concept of space and performance. It is important that each building holds some level of adaptability and dynamicity in its design in reference to its environment, whether it is placed in an urban environment or placed in a wildly open space. However, lately the issue of sustainability and efficiency have primarily been prioritized into every design project. With the advancement of technology we have today, multiple complex designs made up of sophisticated geometry and structures are made possible. Because of this, architects were intellectually forced to sought new inspiration that is ultimately found in nature. Through multiple constant evolution processes, nature has adapted and achieved the most efficient functional method encoded into its biological processes. Combined with the multiple design methods we have today, architects could experiment and develop clever designs through the brilliant ways they could manipulate the three-dimensional objects into one. Furthermore, the help of computer in this generation would greatly enforce the design process, allowing greater experimentation of complex geometry and manipulation of objects in many ways that might have not been considered before. The implementation of a typological repetition into their designs could be observed in the certain example from Peter Eisenman's project, the Biozentrum. From this case study, we could examine how the use of repetition and generative methods is applied in coherence with natural elements as a basis for the project. As seen in this image, the project's plan is made up of four primary geometry, which mimics that of a DNA cell. This method is constantly developed and retried in different manners which yield in different results, each carrying their own distinct character. Here it could be observed how each geometry corresponds to each cell from the DNA. The repetition of geometry serves as the basis for design, in which more complex structures are added and, as seen here, results in a much more diverse and sophisticated structure. As seen here, Eisenman's inspiration comes from the microbiology studies, but the mimicry from nature could also take place from inspiration from the natural beauty of the world. Through inanimate objects such as mountain ranges and the ocean, a project's design could be made to mimic these complex shapes, which would convey the adaptiveness of the design in relation to its placement. These designs should not merely serve as aesthetic purposes, but may also hold some value of sustainability and efficiency with it. The thematic pavilion, designed by the Soma Architecture Group, located in South Korea, imitates the smooth curve-like geometry of the ocean waves. Moreover, a moving mechanism is applied, which provides some certain level of aesthetics but also allows light to enter the building, providing a more sustainable alternative for the building's interior lighting. As stated by the group, they took inspiration from nature and wanted to show how biological moving mechanisms could be applied to an architectural scale. This also implies how the building's aesthetics and performance could work together. There are endless possibilities in which the architectural world could evolve to, made possible by the computational powers. Because of this, the principle of adaptability and sustainability are enforced into all modern designs to improve and develop better design solutions. The concept of moving elements, of dynamicity, and material application could be considered as fairly recent ideologies incorporated into the architectural world. Through this, better solutions for sustainable and efficient design could be achieved. Through the advancement of technology and the evolution in nature, architects today never have had such abundant resources to create and bring their designs to reality.